Hello world, welcome to Decoded. So in this video we are going to unpack the PDF file format. I want to somehow break down the mechanics for you and hopefully give you some valuable insights that sharpen your understanding about how PDF compilation engine might actually work. In this chapter we are going to tackle repairing a corrupted PDF file using these tools, and by corrupted PDF file, by the way, I wasn't able to find any English PDFs that are corrupted because most of the times actually these malformations exist inside Eastern language content within PDF files, such as Indians or Japanese or Persians and so on. So I am using a Persian document to do so. This might look pretty fine to you, but as soon as we try to extract the contents within this PDF file, of course the simplest form of extraction would be just to copy and paste it. I just copy and paste it here. You should see there are many things wrong with this file. I mean, this is a total catastrophe. We have missing characters, we're missing glyphs, and I don't know, hieroglyphs, and it doesn't help us anyhow to determine what the corresponding characters might be. And in order to fix that, we are going to need to fix the character mapping within the fonts within the PDF file. To manipulate my PDF, I'm using fits here at the first stage, and I'm loading my PDF file. I'm iterating through each font within the first page of my file. Once I have the font ID, I should be able to extract the data from it, and from the data I should be able to create a TrueType font object. Once I have created my TrueType font object successfully, I should be able to extract some useful information from it, such as the glyph set, the glyph table, the Cmap, which are essentially the same thing, but the Cmap is different. So let me just run this once. If you look at the output, we have 12 fonts within the first page. This is the font ID, font type, substitution type, name, and encoding and flags and so on. As I told you, glyph set and glyph table are absolutely similar to each other and have similar methods to them, but with a few differences. But if you look at here, first thing first, okay, what are glyphs? Glyphs are essentially the building blocks of our fonts, and each of these glyphs live within our font by an identifier. And these identifiers either give you some information about the correspondent character or not, and if they do decide to give you this information, they can do so in three different ways. They can either describe a certain character like these, a colon, a quad double, a number sign, a dollar sign, and so on. That's called the human readable name, as they do not follow any strict convention. You would find most of them in the AGL, Adobe Glyph list, if you Google it, and they have a standard for the human readable names. And the second form they should give you the information about the corresponding character is the Unicode encoded ones, that is a uni followed by a 4-digit hexadecimal, which can be parsed to a base 16 integer. And the second form would be the character itself. They are the correspondent character as the key itself, as you can see. And this is the cases where the glyph name can give you some insights about what the correspondent character might be, but this is not always the case. See, before we go any further, I have added these information here as a comment. Actually, everything I say is added as a comment in this notebook. And for the composite glyphs, this is nothing fancy, just some combination of simple glyphs that somehow alternate a certain glyph in a way, and you mostly find them in Japanese language and so. And I want you to imagine I have a document and I have written the letter A 5 times in 5 different languages. And if the PDF decides to store every glyph and every Unicode for the 5 letters I have created using 5 different fonts, we are looking at a huge amount of size. I mean, we are looking at least a few megabytes, okay? So this is inefficient. So you can guess why always fonts within any PDF are partially corrupted or partially stored, actually, to be put it the right way. So PDF stores the contours or the movements that represent this certain glyph. So if you look at the PDF file, everything looks fine to you because the PDF stored the shape of each of these characters. But as soon as we try to extract the data from within this file, our text editor cannot determine the corresponding Unicode based on the glyphs or based on the contours or the movements, because the text editors work with Unicodes actually. So here I am saying if the glyph name is not exist inside the Cmap. What we looked at here is the Cmap. As a matter of fact, the Cmap is here to save us the headache about parsing each of these to a corresponding character. The Cmap is like a encyclopedia for the fonts that it simply is a cheat sheet for the font to determine what glyph name is mapped to what certain character, okay? And if they do exist inside our Cmap, everybody's happy. So we do not need to draw them. We do not need to know what the shapes are. We can easily extract the corresponding value from the Cmap and put it there. And if they have contours, this condition guarantees that this certain glyph has been used inside my PDF file. So if I use a letter inside a font in my PDF file, the PDF for sure stores the correspondent contours for that glyphs, because this is how PDF prints out these characters to us by the glyph name, by the glyph contours. This is just an exception. Whenever you see it, you will find this one glyphs inside in every single font. This represents a missing glyph. Actually, this is a standard, and this is nothing but a question mark. And as I have told you, if the glyph name starts with the Unicode and does not exist inside the Cmap, we still have no problem determining what the corresponding character is using a simple regex like this, okay? So if these conditions met, I have an unmapped glyph, and for my unmapped glyph I have nothing but the coordinates, contours, and the flags. And by these information I should be able to draw this. So if I put this to true and rerun this, I should be able to see my glyphs, which are unknown. As you can see, the name does not give us any information about the corresponding character, and these numbers in front of the glyph letter are just the index of the character inside the font, not the hexadecimal integer base 16 value as you see in the Unicode, okay? So here I am importing an SvgPen, and I'm using this to transform my pen in the y-axis, because somehow I need an affine transformation to my pen because it was printing out my coordination upside down. For some reason, so I have mirrored my y-axis inside my coordinations, and using this pen and my glyph object I should be able to draw them. Once I have drawn them using my pen, I should be able to extract the commands from the pen that I have drawn and parse it into an SvgPath command. As you can see here, we have SVG commands and the flags, and whoever designed this was, I believe, this is total art. I believe he was a genius. Whenever you see two ones followed by each other, you have a line. Whenever you see zeros and the ones, you have control points and points on the line for the quadratic Bezier curves. And we have one line, two Bezier curves, and 1, 2, 3 lines, 1, 2, 3, 4, 5, 6 Bezier curves, 1, 2, 3, 4, 5, 6, and one line. And this is artistic. These movements are determined by these flags only. Okay, but anyways, once I have created these images, I should be simply able to determine what the corresponding character is by human form, but I do not have any solutions to determine what the corresponding Unicode is computationally. Okay, and this is the subject for our next session. Okay, and in the block that says repair, I have done the same thing all over again. You can see it. What I'm doing here is essentially iterate through my glyph order, because the glyphs has many dimensions inside the font. They have name, they have the index, and they have the corresponding coordination and the information in order to draw them. And this is what the PDF stream works with, and this is the format that the PDF stream works with. This is the index of the glyph inside that font, and this is the corresponding character as an integer inside that font, both in hexadecimal form. And this is what we are going to fix inside our PDF stream. Okay, so if the glyph name exists in these forms, which I have also called unmapped glyphs, I should be able to easily detect the corresponding index of that glyph inside that font. This is the number of the index for the glyph inside the font. But this is not always the case. As I have told you, there are many forms of glyph identifiers, and the rest of them does not give you any information about the index of the glyph inside the font. But if I automatically assign an ascending number in the ordered list of my glyphs, I should be able to determine each of these glyphs has what index inside the font. So here I am just iterating through my Cmap. I am trying to find the corresponding character for this glyph inside my Cmap. If I am not able to extract it, I just put a value, default value Z for them, and inside this object which I have just created, I am finding it inside my Cmap Unicode mapping and updating it to the corresponding character here. And if you look at here, I am sorting it and I am reading the PDF stream, and I'm finding the parts that references to my BF character Unicode mapping or my Cmap inside my PDF. I am decoding it and editing it somehow and encoding it again and inject it into my document stream. And if I do this, I should be able to see the same thing, but this time if I decide to extract the data from this file, I should be able to see this data has been fixed, but not entirely. We still have some unmapped glyphs, which are these. These are the unmapped glyphs that we have filtered out throughout that condition I just show you, and these are still our hieroglyphs. As you can see, we can understand nothing from them. To fix these, we are going to need to update the Cmap for these certain glyphs in a similar fashion. But since they do not exist inside our Cmap, and this would be a waste of time to just try to extract them from our Cmap. I just put a default value X for each of these unmapped glyphs, and I'm saying the PDF, okay, all of these glyphs are the character X, okay? And if I rerun this and overwrite my fix, and once again come and try to take the information from this file, I should be able to see a bunch of X's instead of my hieroglyph characters, okay? So I should be able to fix this using this method, but yet I do not have any solutions to determine what each of these characters are. So stay tuned for the next video, which we will investigate the solutions to determine the characters which are missing from our Cmap and fix the Cmap entirely and fix our PDF file entirely. Okay, so stay tuned for the next video, and thanks for watching and happy coding.